Hey, what is good, you guys? Welcome back to the channel. I hope all of you are well. And today's video, as you can see, is going to be about building something in Python, pure Python, no web, no frameworks, nothing of that sort. Just pure Python, a couple of packages, and exposing it to the web using Ngrok. So, what we're going to be building today is URL Shortener. And without any delay, let's get started. What is a URL shortener? The concept of a URL shortener is pretty simple. It takes in any long URL, say I have this Amazon product which has a fairly long URL, and it converts into a more streamlined, nice looking URL. So if I just take a copy this URL and go to one of the most popular shortening services, which is Tiny URL, and I just paste this and I click make tiny URL, so it will convert into a nice looking short URL. And if you just click this link, it will direct you basically to this product. So all well and nice, but you might ask, why do we need these services? There's a couple of reasons why you might need it. Firstly, it will give all your long URLs a nice streamlined look. Instead of having all these spammy looking URLs, you can just convert them into shorter ones and have a more streamlined appearance of all the links which you intend to put. Secondly, they obviously save space. So if you want to paste this entire link on your tweet or something, it consumes a lot of a lot of space or a lot of size. Instead of that, pasting this nice looking URL gives you an advantages. So those are a couple of advantages or use cases for these URL shortening services, and that is why you can intend to build your own service. No, obviously, I cannot code everything from the scratch. Well, I can actually, but I'll need a reference to that. So what I've done is I've done a working demo of this. I've practiced it a couple of times, and I've published a Medium article which we're going to use as a guide. So I'll leave a link to this in the description as well, so you can use it to follow along. And as we code, we're going to use this article as a reference. So whatever we have discussed till now, what is URL shortener and so on, is covered in this article. And now we're going to look at which Python packages we are going to use. Right, so there's a few packages which we're going to use. Most of them are available as part of the standard Python distribution, but a few are not, and there are requests, validators, and AIO HTTP. So the most important one is AIO HTTP, and what it does is allows us to spawn async HTTP HTTP client on service. So since we're building a kind of a web service which which will take in requests from the web and do some action upon that and generate a response, we obviously need a web server. So we're going to use AIO HTTP for that. The second one is the validators, and before, so we are using this to validate the input URL which the user has given us. So there's no point of shortening a URL which is invalid. So validators is going to help us do that. And requests is another package which we're going to use to help validate if the URL is correct or not. So we're going to just basically call the URL and see if the URL returns an HTTP 200. So validators will help us validate the format, and requests will help validate if it's an actual valid URL. And the rest, JSON, random string, SQLite for DB, and HTTP, we'll talk about as we progress with the code. They come as part of the standard Python distribution. We're not installing them separately, but we'll talk about them, why we need them. So let's get started with setting up the virtual environment and installing the requested packages. Not requested, but the required packages, and I'll see you after the installation. Right, so those are the three packages which we needed, and they are now installed. So let's get started with doing the actual development. Firstly, what we're going to do is we're going to get our AIO HTTP server up and running. And to get the web server up and running, we need only a few steps. First is importing the web module from AIO HTTP, initializing the routes, which is nothing but a route table definition, and calling the route table definition method from the web module. And what this basically does is all the routes which are mentioned, it gathers them together, and at the end you can just use the add route routes and add all these routes. Otherwise, you'd have to add each and every one of them manually. So a convenient way to add routes when you're using AIO HTTP is using this web.route table dev, and then it'll automatically select each and every one of the routes. So yeah, what this route does is we're going to call it shorten because in the end also that's the name which we plan to use. It just sends back a web response or a text response which says hello world, and in the name equal to main. It's pretty standard. We initialize the web.application, which is a web app. We add the route. We only have one at the moment, and we run the app on localhost and port 8000. So let's quickly write the web application. Let me see why it's given an error. I think this is okay. I think the string, we just need to put it under string, I think. And this should now be okay. Yeah. And now let me run this. So run the Python file, and hopefully if you see the server is already up and running. If I just use Postman and if I query, so it takes in a get request. Yeah, it's a get request. What? Let me just copy this and this slash shorten. And if I send this request, I should hopefully get back a response called as hello world. So our server at least is up and running. Right, moving on to the next step, creating a SQLite DB. This step actually is optional. If you're just playing around with this, you can replace this database with a dictionary. It does serve your purpose as well if you want to play around with it. Nothing fancy. But we're going to use the SQLite database for this. And to create it, we're going to create a database called as URL Shortener.db, and getting the correction methods is also standard, and we're going to create a table URL shortener. So let me do that, and then we'll come back. So I'm just going to make one more change. Instead of creating at the top, I'm just going to create it at the application initialization dot cursor. So we've got the cursor, and nextly on this cursor we're going to create the table. So let me just quickly use the command. So on the cursor which we've got on this connection, we're going to execute this create table command. And if you see the column, the table has just three columns. First is long URL, which is a text column, short URL, which is again a text, code, which is also text, and unique, so that each and every code represents a single long URL. So those are the only three columns which are present. So let me just write this final cursor.table if not exists URL shortener. And I think the syntax is something like this. I'm not sure. I'm just going to copy it from there. I'm not sure of the syntax 100%. And I'm just going to copy the columns from here so that I don't mess up the names. I think it's pretty standard. And this one, we've got one bracket extra and one quote extra, I think. So let me close this. Yep, this looks nice. Let me also exit from this. So this is a setup for the database. A table exists, a DB has been created. On the DB, we've created a table. So if I just now run this, see a database is already created. So that is pretty handy. The next step in this URL shortener is writing two functions, and both the functions will do the task of validating the URL. One will do the validation of the URL format, whether it's in a correct format. So this is like a correct URL format. This is also correct URL format. This is also URL correct URL format, but some of the URL formats which the user supplies may not be correct, so we need to take care of that. And the second one which we actually need to second validation which we actually need to do is that we have to make sure that if not only the format of the URL is valid, but also the URL is actually a valid website also. That is, you can send a request to it and get back an HTTP 200 response. So those are the two validations which we're going to write. Now, for the validation of the format, we have used a third-party package called as validators. We have installed it, while beginning this demo, and the request package also, it's pretty standard, used by many of them, and we've also installed it at the very beginning. So I'm just going to write up the code for that. So the code is pretty simple. In the what we do is we import the validators package, and on the validators.url we supply the long URL which was passed as the input, and return the response. So if the response, the validators.url will return true if the the long URL or the parameter which is supplied is in the correct format, or it's a valid URL. It will return true, otherwise it will return false. Actually, we can just we don't need to do this as well. We can just return the validators.url. So I'll just make that change here as well. And for validate, so this is for the format validation, and for the actual URL validation, what we're going to do is we're going to send a request to the URL using the request or get module, and check if the HTTP response code is HTTP status code is 200. So if the status code is 200, we're going to we know that it's a valid URL. So for I think one more change here, I need to update the gist as well. We're going to query Amazon, and for Amazon, I think it needs the headers as well. So we need to specify the user agent. Without that, Amazon does not accept the responses, and it sends back a HTTP 503. So we'll see that as well. But first, let me write the the URL, and we're going to try and make some name changes here as well. Function. So sync def validate. A nice docstring doesn't do any harm. And we forgot to import, so import validators and return validators dot URL and long URL. So we don't need to take back the response. We'll just return whatever response, because it'll return true or false. Instead of storing it somewhere, we can just return it. And the second one, URL, again this takes in the URL in a string format, and no harm in writing documentation. Let me just write a pass here. So one here, and this looks nice now. This function, wallet address, and so this is a little bit complicated. What we did here was, firstly we need to obviously go and import the requests package, and import request.exception. So what we're going to do is response is equal to requests.get long URL, and if also one more import, because from HTTP import HTTP status. So yeah, what this HTTP status does is it's an enum, and it has all the valid HTTP responses which are available as to use of the right of the shelf. So we don't need to compare using hard coding such as response is equal to 200 or response is equal to HTTP OK and all that. You can just use this enum whenever you have to do comparisons of the HTTP response. Response dot OK. So HTTP status not single equal to but a double equal to, and if I just go back to OK, so it's a 200 OK, request will get OK. So we're going to compare that. The response which is received here is basically equal to 200. Return true, and we're going to I think it's best to surround this into a try catch block, because there's a possibility of this failing. Okay, except exception as EX, and return false. So if the HTTP status is not 200, it will return false. So I think that completes this function as well. Nothing more is needed here. We have, I don't think, but let me just try it. Print ex. Just print the exception to the console at the moment. We can write logging later and else return false. Or actually, don't even need to do don't need an else here. Just return false. You should avoid using these if else blocks unnecessarily, because if I wrote an else here, no harm in doing that. It's just one indentation more, but we know that if it returns from here, it will always be true. But if it comes at this point, we know that there's something has gone wrong, and it's not. So it's best to return a false directly. Now I think we need to do one more. Headers is equal to, so this is just for because we're using Amazon. For other websites, I'm not tried hundreds of them. I've tried Twitter. Twitter works without the headers, but Amazon didn't. So I think we need to add the user agent headers. I am not 100% sure. So what I'm going to do is I'm going to quickly look them up and what the headers are needed, and I'm just going to come back. Right. So I've copied the headers, and these are the headers which you're going to use. And I think here headers equal to headers. So this should do our job. This should allow us to send the request. Otherwise, the Amazon complains and sends back an HTTP 503. Only Amazon. Twitter works fine, as I said. Those are the two URLs which I've tried. So these are the two validation methods, and those should be more than enough for this particular project. Proceeding forward, just a small change. We have to check the response.status code is equal to, we have to compare the response.status code and not just response which we have done. So I've made a small correction. And before moving forward with the tutorial, what we're going to do is write a test.py file, and we're going to test if these two functions indeed work as expected. So we're going to use the standard unit test module, nothing fancy, and I'll write a couple of tests, and I'll see you in a couple of I'll see you back. Our test cases are now ready. So I've just used the same Amazon URL as a valid one, and I've removed the amazon.in from the name for the invalid one. And what we're going to do is we're going to assert false or true based on whether we are supplying the valid URL or the invalid URL. So let me just quickly run this test case or the suit. So it will run entire four of them. So it ran four tests, but one has failed. Uh, so the one with the valid URL is failed. So let's take a look at this. So yeah, one thing also I've done is, in order to test this, I've removed the async word from here. Otherwise, it'll ask us to await over there and given coroutine related error. So I've removed the async word from, made them as normal functions instead of async functions. So that is the one change I've made. And I think, yeah, okay, looks like we've not supplied the correct ones. So yeah, I think this has to be changed from header to headers. And let me quickly run the test case again. Now it looks like okay, all our tests have passed. So basically, all our functions are working correctly as expected, which gives us some degree of confidence in moving ahead. Next step is now integrating these to validate URL functions with the main endpoint which we have, which is called the shorten. So what we're going to do in this is, firstly we are going to read the post request or the request which is coming in, and extract the URL parameter. So what I mean by the URL parameter is, let me just open a sample post request, and if I go in the body, I'm supplying this Amazon link. I've used a different one here for the previous testing, but the key uses URL and the value is the Amazon link, and I've sent it as a form data. So what we are going to do first is we are going to extract that URL and then pass it to the validation functions which we have written. And once the uh, if and only when the validation functions have passed, then we are going to then we're going to call the shorten URL function, which is essentially which will do the magic. That is, it will convert this long URL into a short URL by generating a code and using the Ngrok tunnel. So firstly, let's just go and write this piece of logic. So let's just replace this, and what we're going to do is essentially is just copy paste this reading logic. So nothing different here. We're just going to copy paste this, and we have done some changes to the name. So we're going to use this, and the shorten URL doesn't exist. So what I'm going to do is I'm just going to write one for now. So def URL, which also takes, So this works okay. To test this, what we can also do is, for now, let me actually remove this, and what I'm going to send back is this long URL as a response. So let's see if the shorten now works. Let me quickly try to run this web application, and this still looks to be working. And if I just open Postman and I copy this Amazon link, actually what I'll do is I'll just go HTTP. I'll not bother about this one. What I'll instead do is I'll just copy this, open a Postman, and paste this URL and send this. Okay, so the method is not allowed. I think it's a get method, which I don't think should be. Let's just change this to post, because we're supplying some data. So, and let me restart the server. And now we're going to try to send this and see if we just get back. And yes, if we have got the same URL which we sent back as a response. So this piece of code is essentially working. Now let me uncomment this and integrate this. So what I'll just make this function do is return long URL. Nothing different, but we've just made some changes. If the URL is valid, then only return the URL as a response. And let me return the short URL here. So what I've done so far is I've passed the long URL which we have received to both the validation functions. If both the validations pass, then I'm passing it to shorten URL, and shorten URL is not doing anything, but it's just returning the URL, the long URL itself, and we're going to display that, send it back as a response. Nothing different, but what we want to verify is this integration works or not. So we're going to do two tests. One, if the validation works, and it should not return anything. If the validation doesn't work, if the validation works, it should send back whatever URL we are supplying. So let me run this code, and let me find Postman. And firstly, we're going to send the valid URL, and we should get back the same URL as a response. And it's working as expected. Now let me send an invalid URL. So I'm going to remove the Amazon here and see what happens. And the server got itself into trouble because we didn't have any error handling, but this is working as expected because the short URL was initialized before. Because the short URL was not initialized, this validation did not pass. So this function is also integration is also working. Okay, time now to talk about the Ngrok tunnel and the logic to shorten. By the logic to shorten, I mean the shorten URL is just basically returning the long URL. We have not done anything here, but we need to write this function. And what this function is going to do is take the long URL, get the Ngrok base URL, generate a unique code, write it to a database, and generate the final short URL and send it back as a response to this short URL, to the to the caller function, which is the shorten. But before we get started, we'll talk about what Ngrok is. Now, what Ngrok does is takes a website which is hosted on local host, or which is running on, say, your local ports, not local ports, I think that's wrong, which is running basically on local host, and it exposes it to the internet. I don't know, I had trouble saying exposes, but yeah, it is what it is. So yeah, that is what ngrok does. So if I just run this code as it is, the part which we have written, you see that this website is running on the local host on the port 8000. Now, if you try to access it from some other computer anywhere in the world, this website won't be accessible, which makes sense because it's only running on my local machine. Now, there's two options to take this website or take this application to the internet. One is hosted on a web server, which is connected to the internet, hosted on a cloud or some other web hosting services such as Heroku or Netlify, or I think any of these n number of services which are available. Or there's an easier option which you can choose if you're using if you just want to demo it or show your work kind of to your friends or peers or something like that. And that solution is called as Ngrok. Now this tutorial is not for Ngrok installation, how to get it up and running and started. There's a Twitter thread which I did for it, and I'll leave a link to that in the description. You can visit that and set up Ngrok on your own, but I'll just show you what how Ngrok can be started. Now, this web service or this application which we are running is running on the port 8000, and what you can do is ngrok http 8000. So basically, what it'll do is it'll expose what do you say, a web address which is indicated by this forwarding. So this is now this actually also says that this address corresponds to, or this particular web address. It's again a tricky looking one. It's not easy to remember. Corresponds to this particular service. So if I just click here and let me just copy this, copy, and I'm going to go to Postman. And as of now, we're doing this. Okay, uh, server got itself into trouble because I think makes sense. Let me copy a proper URL. Firstly, this one. Yeah, Control A, Control C, and let me put this. And if I just run this first, it returns the same URL. But now what I'll do is I'll just use this the ngrok forwarding URL, or the ngrok URL, which corresponds to the same localhost. And now if I just replace this entire thing, it should still work. That this code should still work. And if you see, yeah, it is actually working. And ngrok also shows that we sent a post request to shorten. So this is what ngrok does. It takes a localhost website running on whichever port to and expose it to an internet. How did we run this? Command is shown here, ngrok http 8000. You have to make sure that this port matches to the one which is running here. Don't worry about this one. This just happened because we didn't supply the correct URL and one of the validations failed and the short URL was not initialized, and that's what it's complaining about. But that is about Ngrok and how we are going to use it for the demo purpose or exposing our web application over the internet. So we talked about Ngrok. Now what we need to do is we need to get this Ngrok forwarding URL, that is the corresponding internet facing URL, into our code, because that is what we intend to use in the shorten URL function. And the way to do it is this code which I actually found on Stack Overflow. It's not mine. I've just copy pasted it, and what it does is this is actually the standard URL which Ngrok uses to expose all the tunnels. What I mean by tunnels is if I just click copy paste, this public URL would be the same which is available here. So basically this forwarding basically means that this local URL is exposed by, or is correspondingly mapped to this public URL, and it's available here. So we need to extract this, and that is what this particular code does. It sends a request to this particular URL and gets the public URL bit. So I'm just going to copy this as it is. I'm not going to write this because it's not my code, and let me put it somewhere at the very top. So this will help us get the ngrok URL or the ngrok tunnel, and it's complaining about missing a JSON import. So let us import that as well. Now let us implement the final, not the final, but I think the second last bit. There's one more bit which you need to do after the shorten URL, which is actually the actual redirection. That is when someone clicks the short URL after we generate it, we need to redirect it. Okay, now moving on to the core logic, which is the shorten URL function, which needs to be written. So what the shorten, this is where all the magic happens. Basically, we will get the ngrok URL, which is the public URL. We've chosen a size 6, but we can choose any size 7, size 8, which would basically be the length of the code. So if you see tiny URL uses 8 characters, but we're going to use 6 for a demo purposes. There's no harm in using 6. Then we use string ASCII uppercase and string digits. So what this basically does is, I'll just quickly demo it to you. If I do, let me just close this, and if I do Python and import string dot digits would give us all the digits from 0 to 9, and similarly the next one I think is string dot ASCII uppercase. So we're going to use a combination. So string.ascii uppercase, it will give all the uppercase letters. Similarly, you can imagine that ascii.lowercase will give you a lowercase letters. And what we're basically doing is string.ascii uppercase plus, not this part, string.digits. So we are generating this string here which is a combination of all the 26 letters and the digit 0 to 9, and out of that we are choosing six randomly using the random dot choice. So that is what we're doing here to generate our code, and that code is then appended to the ngrok base URL, which will give us the corresponding short URL. And then what we're going to do is we're going to write the long URL, short URL, and code to the database. So that is what the whole purpose of this shorten URL is. This is the core logic. We get the base URL, we choose a size of the unique code which we are going to identify the long URL by. Use this combination can be anything. Now this is just a simple implementation. This can be anything, any complex logic can be used, but I think this is sufficient. Then from this chars, which is just a combination of 26 the 26 letters in uppercase and digit 0 to 9, we choose 6, and then we prepare the short URL, which is then returned. So let us quickly write this as well. Or no, why just write this? I have this working, and let me just copy paste this, and we'll replace this. Now it will complain about two things: string and random are not imported. So let's import string, or and import random. Hopefully it should now stop complaining. And let me exit from here as well, or let me just type Control Z, and yep. And let me still now run the code and run. Oh, I've done this wrong. Let me just quickly shut this down as well and run Python file in terminal. Right. So a web server is now running, and we'll see if it is able to transform the long URL into corresponding short URL. What I'm going to do is so I've done a demo testing of this, but what I'm going to do is the Ngrok service is still running. This is a public URL, and what I'm going to do is this is the long URL which we need to transform, and I'm just going to click on send. And if you see, we've got back a shortened version of this URL. Just worth keeping in mind that I've passed the URL, and the URL is a key, and the value is the long URL in the body as form data. So that is what we are expecting to be sent to this shorten method. So just worth pointing out. The final piece of logic which we need to write, or the final function which we need to write, is the redirection logic. That is, when someone clicks on this shortened version of the URL, they should be redirected to this corresponding long version of the URL. So that is what we're going to implement now. So if you just to demo it, if I just click it right now, I'll see that this URL doesn't exist, or it gives a 404 not found. So we haven't implemented this route, and we need to do that. So let's quickly see how we can do that. The function which we are going to use to redirect when a person clicks, or when someone clicks on this the short URL is called the redirect to long URL. And what it does is, so it's a get endpoint firstly. So we're going to this is going to be a new endpoint, and we're going to extract the code, this which comes in from the URL, and query the database for that particular code. If the code is found, we extract the long URL, and we use the AI HTTP web module again, .http found, and we redirect to the long URL which was found. So this is pretty straightforward. So I'm just going to copy paste this again, and we're going to remove the print statement because we don't need it. And let me just remove this print statement. And now let me shut this down as well, and run the Python code. So this is running. Just to explain the code again, this is a get endpoint. Our root table definition will automatically handle this addition of this root to our AI HTTP server. We don't need to manually add this, so this will automatically be handled. And once this code is available, we query the database, and if it is found, the database query will return tuples. If multiple are available, we know that there's only one, but we so because it's a tuples, it is a tuple. We just extract the first element from that, which would be the long URL. So the output of this would be something like this: Amazon.com, comma this. So we need to extract this particular element. So that's why we are doing this zero indexing. So now it's running, and we'll just test it out. So this, let me close this. I don't think we need them. Don't save, and we'll generate a fresh short URL corresponding to this Amazon one. So this is our URL. And let me control and click it now, and let's see what happens. So if you see, this is working. Just to demo that it works for everything, let's generate not but let's go to mobiles and find some other link. Smartphones. How about this one? And let me paste this URL now, and let me try to send this request. So a new code is generated, and if I now click this, hopefully it should take us back to the same one. So this is how the URL shortening works, and the Ngrok also shows us that the request which you send. So that was the entire working of a URL shortener. Let me quickly summarize again what we have done. We have used AI HTTP to generate two endpoints. One is a post, which is called shorten, and one is a get, which is called slash code. So what the shorten does is it calls the validate URL format and validate URL functions. So it first actually reads in the URL which is supplied from the post request, and calls the validate URL and format and validate URL on it. And if both of them are successful, it calls the shorten URL. The shorten URL is where the magic happens. We get the ngrok URL, which is basically our public URL, helping us to expose this application to the web. We then generate a 6 character unique code by using a combination of uppercase A to Z characters and digits 0 to 9, and that we append the ngrok URL and the code and make the corresponding short URL, which is returned here. So that short URL is used to redirect. So if someone calls this URL, basically a get method, we extract this particular code and look up in the database. If we find the code, we just redirect to the user to the long URL, which is corresponding to that particular code. So this is how the whole working of the application is. I think there is a possibility of kind of refactoring, I think, here. So what you can do is just return this one. We don't need this much. So we don't need, I think, this much. We don't need to the if else comparison at all. Just to make sure it's working, let's try this again as well, because it'll either return true or false only, nothing else. And if it errors out, we are obviously returning false. So let's just test this out. And this is now working. And let's generate a fresh URL. So this is Redmi Active Carbon Black. And if I click on this one, this is still working. Now if I supply a false URL, it will error out, but I think that again needs to be refactored. So if one of this fails, or if an invalid URL is supplied, I think what we can do is we can just pass in uh, text is equal to invalid URL, and what we can do is, or we can just use this short URL and just save this, click this, and let me run this again. So what I'm going to do is, instead of passing a valid URL, I'm going to just do an invalid URL, and let's see what happens. If you see, it passed the invalid message back. So this now looks a little bit more tidy. Otherwise, what would have happened is it would have failed if we would have not done this, and we would have just passed an invalid URL. The short URL variable would not have been initialized, and that would have caused a problem. A better way to do this would also be something like this: initialize it to a default, and the short URL would be become the short URL would be initialized or assigned a short URL value only if this method returns true, otherwise it will fail. So otherwise, without that, a default invalid URL would always be available. So just to demo that again quickly, still using the wrong URL, and it gives the invalid URL as expected. Now if you want, what you can do is, let's just take a correct URL and make sure it's still working fine for the happy path. That is, it's returning a correct URL. And when we click on this, yeah, so this seems to be. So that is it for this video, guys. Thank you for watching. I hope you liked the tutorial. If you did and it did add some value to you, do subscribe to the channel. If you haven't already done so, leave a like, comment for the algorithm. It will help me immensely and it will keep me motivated to generate more content like this. Thank you for watching.